Hey, what's up everybody? Today we are going to be starting on a new series here on this channel that I'm calling Bot Breakdown, for lack of a better name that I could think of. But basically what we're going to be doing is doing the opposite of a build report. I have a really bad habit of building the robot and filming while I'm building it with the intentions of making a cool build report. And things all seem to fall apart. I run out of time, I forget to film. Just one thing or another, I can never get something that feels cohesive. So I realized when the robot's done, and it's already competed, and I'm not under as much of a deadline to do anything crazy with it, I could just do it backwards, and then I could splice in some of that footage of the parts being built as I talk about them. So today we're going to start off with my brand new 12-pounder Hel Hound, and we're going to take the bot apart, talk about what's inside of it, and where I have clips of me building the different parts, I'll throw those in here to give you a full idea of what went into making this robot. So this robot is basically in the state that it came home from AVC in. I partially reassembled it for the event report, but we'll go ahead and take it apart. So up here at the top is the weapon motor. This is a prop drive 50/50. I basically just had no idea what motor I wanted to power the weapon on this thing. And from watching all of Robert Cowan's videos on building crippling depression, I knew this motor worked. I knew it hit hard. I figured why not? Plus the kilovolt rating basically put me at a point where at 11 volts or 12 volts, it was theoretically spinning at about 200 miles an hour at the tip of this blade. So that seemed pretty decent to me. So the way this whole top section is constructed was a bit of a problem if you saw my event report. It is two UHMW blocks on either end. This one, I don't remember the dimensions of. This was honestly scrap, but I just had to have a piece big enough to fit the main weapon shaft in. The back here is like 1/2 inch, and the sides are like Home Depot 0.09 inch Lexan. Originally I had like 1/16 inch aluminum here on the bottom, but thanks to David Small, this is now 1mm titanium to make it a little more rigid. So this is all held in place with this grade 8 bolt. This normally is threaded all the way through, but right now it's just kind of hanging in there. That comes right out here in the front. And that is, I think it's a 1/2 inch grade 8 bolt, if I remember right. Looks about 1/2 inch. So I wanted something nice and beefy because it is holding on the primary weapon assembly. The wires here for the motor are disconnected right now, but basically the wires here flow through the center shaft. So when they're disconnected and that bolt's removed, this entire top section can just pop right off. So I'm losing some of the bolts down here at the bottom as well, but you have the bolts that hold the motor in. You have the pulley here on the bottom. This was like a cast iron piece of crap from McMaster, but I was having trouble finding the pulleys I wanted. I really want to try to find something that's all aluminum. Yeah, this was my hastily built new titanium bottom plate. I ruined quite a few drill bits trying to make it, and it still wasn't correct enough to prevent the belt from coming off. But this whole section is self-contained, so we could set that aside. And then we have the lower section of the robot now. I have a couple 1/2 inch UHMW spacers that sit on the top of the shaft. So there's 2 of them here, and those just pop right out. Belt slips right on there. The belt is a little bit of a pain to put on. I basically, when I'm assembling the robot, it goes over top of the pulley here. Weapon motor box goes on, and then the weapon motor pulley actually has to go onto the belt, and I stretch that and kind of get it onto the weapon motor. It's not ideal, but it does mean it's tight at least. So this is a 3L170 V belt. I'm worried a little bit that when I get this thing doing what I want it to do, it may not be sufficient to power this robot. I've seen a lot of 12-pounders with powerful motors on them start smoking belts at some point, but it was the best thing I could come up with at the time. It was originally going to be chain drive, and I'm really glad I didn't go chain drive. I think that would have been a mess. The pulleys here, this is a 2-inch pulley on the weapon motor, and then I got the 4-inch pulley here on the blade. The blade's the next part to come off. So there we have our 4-inch pulley mounted to the blade. This was an interesting piece to create. Alright, so I'm back with my close personal friend, the 1 1/4 inch hole saw. And basically, I already did what I had to do, but I could show you the aftermath. I had this pulley. It's I guess a cast pulley, which isn't the best, but it's what was available at the time. And yeah, I needed the bore on it to be 1 1/4 inch to work with the weapon shaft for Hellhound
And it came with, I think it was like a, I don't know, it was a very small bore. No, it was a 3/4 bore. I should know that. So yeah, 3/4 inch bore on it. Nowhere near what I needed. So what I did was I took a 3/4 inch hole saw, drilled out the center bit, basically made a plug of UHMW with a, is that a 1/4 inch? Whatever the standard, centering bit on a hole saw is, going through the center, UHMW, and then I cut out the hub, or the mounting set screw bit of the pulley. So yeah, so it was that, and then this was sitting in the middle there, and that's how you would normally mount it. Now, just has a very large bore. I'm going to drill some holes around the exterior, and that will probably mount to a spacer and then onto the blade. But that was my cheap and easy way of getting the pulley I needed. Hopefully it works. I am a little concerned. I'll have to take a Dremel in here, because there is some flashing along the seam lines in there that looks like it would just tear a belt to shreds. So I got to take care of that before we spin this up. Another one of those critical moments in the build where I'm nervous to have to do something precise, but yeah, I'm about to drill out the bolt pattern for the hub here, and then that will be transferred over to the weapon blade.
It came out really good, I think. It came out nice and balanced. The hole is very well centered on the blade. The pulley seems centered, so I actually think that worked pretty well. Right now, this blade is just 1/4 inch 6061 aluminum. The bar is just as it came from McMaster, except for the hole drilled in the center of it. Next time I'm hoping to beef that up. It did take some damage there on the edges after only a couple hits, and we all know aluminum is not sturdy enough for the kind of thing I'm doing here. Or at least just a pure aluminum blade. If it started dealing out some actual decent hits, I'm sure these sides would just disintegrate. And then here at the bottom of that assembly, there's a 1.5 inch inner diameter oil light bushing. This seemed to give it a fair amount of slip. It worked well enough for what I think it needed to. Don't know if this will be up for another tournament or not. I probably need to get some replacements for Maker Faire Orlando, but it held up well enough for the first event. So after all that, we are down to just the bare, normal little box of a robot here. It was at AVC where I decided to split the top armor to make it possible to access the inside of the robot without removing the entire weapon assembly. This back corner here was always going to be blocked off, so this side basically had to stay on just because of the way the motor assembly sat. I'd have to remove that to get to this side, but at least I can get the battery in and out through, well, to me it's my left side, your right side. But this is just 0.09 inch Home Depot Lexan yet again. My thought process was, even if I fought a hammer robot, the chances of them getting the top of this robot, getting through the weapon motor box, the weapon blade, and hitting the top armor with enough force to do real damage, it seemed unlikely to me, so I wasn't really worried about it. So down to the guts of the bot itself, I did cram in some foam to keep things from wiggling around too much. And as you're going to see, wiring is always my weak spot. I usually end up just cramming crap inside the robot, which I know isn't good, but that's what I did. So for the first time in this video, we may actually have to break out the screwdriver. I have this piece of UHMW here in the middle. This was kind of an afterthought piece. I realized partly because I didn't countersink these bolt heads, kind of because I was nervous about setting it off balance and not having time to correct it, and also because they were a little too close to that center hole for my liking to countersink them. I realized I needed something for those bolt heads to rub against, and if they were just kind of set loose, the blade would get out of whack really easily and wobble around. So I added this piece here, and it's held in with 2 wood screws. So those come out, and then this piece will just slide out. It's a very tight fit. This has a channel really poorly milled into the bottom of it. I'm still very much learning how to use the mill, but that channel is to allow the wires to run through. So that was another reason for bolting this down, was to make sure it didn't get out of whack and twist the wires inside the robot that come up through the weapon. So basically this sits over here. The wires pass through, they can't move, so the wires are nice and secure in there. Wires themselves, it's a simple matter of pulling them out through the front here, and now they're out of the main shaft. Once again, ripping off Robert Cowan, I used the same Hobby King 200 amp speed controller for the weapon that he used, mostly because I knew it would handle that weapon motor from what he did. So let's go ahead, we'll unplug it from the receiver there, and then I'll do these little pieces of electrical tape, and we'll remove the bullet connectors. So now that's free, our first electronic bit free. I'll pull this out here. I just used the Hobby King receiver. I use this on pretty much all my bots right now. This one's the 3-channel model. Didn't really have to be the 3-channel model, it's just what I had lying around to use. Here in the back, something I added halfway through the event. I didn't have a light on the robot for my first round, but I realized the only way I could really tell it was on sometimes was by the beeping of the speed controller, and I wanted something a little easier to notice. So I added a green light sticking out the back. That's just the FingerTech plugs because it's lazy and easy. So now we come down to these two big blocks, and I realized I forgot to put the battery back in beforehand, but there's a strip of Velcro in the back here. That's where the battery would stick down. The rest of the electronics kind of kept everything in place, so I didn't really have to worry about the battery wobbling around too much. But I have these two big black blobs of electrical tape, and these were my primary power joints. So basically what I'm using is all like 12 gauge wire in this bot. And I got some bolts. So basically I just ran the bolts through the terminals. The terminals are soldered nice and tight in there. And then I put a nut on the end and then wrapped in electrical tape. And that's what held the power in this robot. So basically just one for positive, one for negative. And it worked out pretty well. This is something I've been trying to use more and more on my bots lately. It's even in the current version of Demon Spawn, just at a smaller scale. But this has actually been much easier than any of the wiring I've done previously, and I feel kind of dumb for not starting to do this earlier. So once I remove those two bolts, you realize it's just a mass of wires sticking everywhere. So I got the two empty ring connectors. These are what put power to the weapon speed controller. And then here on the back, I don't have a screwdriver handy to take it off, but I have a FingerTech switch, and that was part of my problem with knowing if the robot was on. The bolt in here is starting to round off, and I didn't realize that until I got it to the event. So I was having a lot of trouble actually getting it to engage and fully plug down. So that's why I added the light so I could tell when the robot was definitively on. I'm going to see if I can just replace the bolt on this for the next event, but if it doesn't work, I'm going to have to look for something a little more robust, I think. But basically this has a XT60 connector, I think. It comes off the edge here. This is what plugs into the battery. So basically there's a positive lead going to the switch, and then a negative lead that just goes to the negative connector. And then off the bottom of the switch, there is the actual powered lead here. So now we've reached the point where to proceed, we're going to have to actually start really taking this robot apart. So I'm going to start with the side armor here. It's actually held in from the front and back by some screws. And this side here is more put together still, so I'm going to start there to give you a better idea of what's really in the bot. And this is the part of the episode where everybody who uses chain drive successfully is going to laugh at me. Hellhound is the second robot I've ever used chain drive for the drivetrain. I've used it for lifting weapons more recently, but the only other time I used drive with chain before was my very first robot, Demonic, the first incarnation of it. It was a disaster. So this one did a little better because it actually drove and turned and didn't lose the chain immediately, but still was not very good. So basically this side here is UHMW, 1/2 inch thick. I have these end caps made of aluminum here, and that keeps the axles in place. So we can slide that off, and you can see the chain here has completely come off the sprockets. So I guess let's just finish taking that off instead of putting it back on like I was about to. I have these, I think they were from Andy Mark. They're aluminum sprockets. 1/2 inch bore, keyed, which is the main thing I was looking for. Having them made out of aluminum was nice to save some weight. One of the things I did have to do because of the way I drilled the holes on the inside of the UHMW, which was not very accurately, I ended up having to put a screw in the top there to stop the key stock from sliding into the UHMW. If I had been using bearings or bushings, I wouldn't have had this problem, but I also didn't really have the weight to add bushings or bearings, so ended up just having to go with that screw to stop the key stock from sliding off. So these sprockets here on the outside exist purely to drive the front wheel from the back wheel. So we can take apart the front assembly, not much different. 1/2-inch keyed shaft, key stock. We got a spacer in here, and then these are some 2x7/8 Coulson wheels with the hub from Banebots pressed in them. I was originally going to go with even smaller wheels, and then I realized that I couldn't find a sprocket that wouldn't basically be having the robot driving on the chain instead of the wheels. So this is about as small as I can go, I think, unless I find some really cool, super tiny sprockets that still have a 1/2-inch bore. The back wheel, more or less the same. Pop out that shaft, same wheel on there. And then we have another one of those aluminum sprockets, another smaller set of number 25 chain, and that goes to this sprocket here, which is a bit loose. This sprocket is connected to the drive motor. And this is actually a cast sprocket. This is from McMaster. Because this is a 1/4-inch shaft, it's actually I think like a 6mm bore, so it is perpetually a little loose, just because it's not exactly 1/4-inch, but for some reason I could not find 1/4-inch for the size I wanted, so I had to go with this. Obviously, because the 1/4-inch shaft on this motor, I had to do this whole slave drive system because I just do not trust this shaft with the wheel directly on it. I was getting to the point where I was getting desperate and I was really thinking about doing it, but it just, the more I thought about it, the more it just sounded like a bad idea. So the motor that's on here is a Banebots motor, but I do not know what motor it is. This is something I bought off another local competitor, and he had used it, I think, in like a first robot or something. And these things were not up to the task of driving a 12-pounder. I smoked a motor both fights, and just the drive power was pretty minimal. So next I'm going to take off these 4 bolts here in the front, and then I'm going to remove this drive motor pod here. And these are actually screws, not bolts. These are like masonry bits, or masonry bolt screws, whatever. Basically, I needed something beefy to hold in the center block of UHMW. It was originally aluminum. I had it drilled and tapped, and then when I ran into weight issues on the bot, that was a really easy place to sacrifice weight, or to gain some weight back by using UHMW. It seemed to hold up okay. We'll see when I get this out of here if it really did. So there we go. I forgot to grab the Allen wrench to take this set screw off, but we have the sprocket here. It is actually capable of sliding a little forward and back. And the motor is face mounted to the UHMW block here. And we got the gearbox, the motor itself. Back here we have the BotBits 30 amp speed controller, and that's what runs it. I think these should still be good when I upgrade to the larger motors. And then the back of this plate has the same aluminum blocks to keep the axles in place. And then once we get past everything else, we have this UHMW block that I cut pretty poorly that sits in the center. This actually seems to be in good shape. We've got the 1 1/4-inch shaft here in the center, hollow of course, to let the wires pass through. And then we have another 1/2-inch grade 8 bolt going through the middle. So that unscrews on one side, and then unscrews on the other, and the shaft pops right out. So just a hole in the center there with a bolt going through it. And then on the axle itself, you can see there is a hole going through, all the way through. At the bottom here, we have a single hole where the wires pass through for the bottom section. And then we have the initial hole I tried to drill for the top, and the second one, which probably was a bad idea, but whatever. I actually drilled it really badly. It kind of cut through the top of the material. Drilling a thick piece of metal that's also round is a pain in the butt, I will say that. Yeah, I mean, this held up pretty well. This looks good to go for another round. Even this part at the top doesn't really worry me too much. We'll see how it goes. And here's the nearly complete breakdown of all the parts in the bot. Not sure I'm going to do this at the end of all of these videos, but since I knew Hellhound had to come apart, might as well take it fully apart now.
I didn't take apart the weapon motor box just because, I mean, it's just a box. I didn't really feel the need to. And I didn't take the end caps off of the drive pod rails. But for the most part, here are all of the components laid out side by side.